Homework 14, section 7.2, applications of the standard normal distribution, video 2. Using the z-table in a non-standard normal distribution. So if the z-table is only good when the distribution is standard, mean is 0, standard deviation is 1, how can we use it under other circumstances, such as the mean being 272 and the standard deviation being 9? You may have noticed that this is the same setup as the previous video about the mean term for pregnancies being 272 days with a standard deviation for 9 days. But this time we're going to define a random variable called capital X to measure the length of a pregnancy term. So for some people it might be 280 days, for some people it might be 271 days, for some people it might actually be 272 days. Assuming capital X is normally distributed, so it's a bell curve, calculate the probability that X is less than or equal to 280. In other words, what's the probability under these parameters that a pregnancy will be no more than 280 days? Well, let's think about what this means visually. If we're normally distributed and we are in a normal distribution with a mean of 272, that means that the middle of this bell curve, X is equal to 272. We could represent a standard deviation of 9 by going one standard deviation both sides and saying there's 68% of the data according to the empirical rule. But let's just write sigma equals 9 over here so that we don't have to draw all those extra lines and write those extra percentages. When we're talking about the probability that X is less than 280, we're asking if we go over to 280 and go straight up, what is the area to the left of that 280? Remember, in a normal distribution, in a probability density curve, the curve representing the distribution of the normal distribution, the total area is 1, and the area to the left of the value as a percent is the percent of the values that are less than, in this case, 280. On the right, it would be the percent that are greater than 280. Every probability has multiple interpretations. In words, this would be the probability a term is 280 days or less. But this can also be interpreted as the proportion or percent of terms 280 days or less. So anytime you're working a problem that involves probability or proportion, you can think of it as an area, because both of these are equal to the area to the left, because less than, of 280 in a normal distribution with mu equals 272 and sigma equals 9. Sorry for the sloppy writing, I was trying to get that written quickly. So anytime we're answering a probability question or a proportion question in this context, we can just answer the equivalent area question. But here's the problem. This is not standard. This does not have mean equals 0 and standard deviation equals 1. And our table, which I'm going to use in the index in the back of the book, our table is only good for a standard normal distribution. So how can we use that? By making the following observation. Recall in the previous video that the z-score for 280 was 0.89. Let's go ahead and recalculate that real quick. To find the z-score, just subtract the value around which we're looking, which is 280, minus the mean, which was 272, and divide it by the standard deviation, which was 9, and that was about 0.89. What that means in the context of this problem, so the probability that X is less than or equal to 280 is equal to the probability that Z is less than or equal to 0.89. In other words, we can convert a non-standard distribution question into a standard distribution question by using the conversion formula to calculate a z-score for a given value. And this is something that we can look up in the table. Now, I don't have a picture of the table handy, but I'll remind you real quick how to use it. In the z-table, the left column represents the digits on both sides of the decimal. So we would go down to 0.8 in the z-table. And the top row represents the second decimal digit. So we would have to go all the way over to 0.09. And then we would look across the 0.8 row, down the 0.09 column, and see what number is in there. I've got a z-table handy here, so give me 1 second. Remember, the z-table is in Canvas. The value that I found is 0.8133, which is the area to the left of 0.89. Now, unfortunately, I don't have a picture of the z problem drawn here, so I'm going to erase these words and quickly show you what it is we just found. In a standard normal distribution where this axis represents z values, the mean is 0, so 0 is in the middle. 0.89 is the z-score that we're looking to the left of because it says less than. And so this picture, although technically different from the one over here because of the mean and standard deviation 1, both areas are the same. Now we just found the area under there using the z-table, and I forgot what I said. Oops, I lost it. I think it was 0.8133. Yes, 0.8133. So the area of that shaded region is 0.8133, which means the area of this shaded region is also 0.8133, which means the answer to the question is that. So the probability that pregnancy is 280 days or less is 0.8133. Another way of interpreting that is saying that 81.33% of all pregnancies have a term of 280 days or less.